and Zain Asghar. Our project is information extraction from scientific articles. Here I will briefly explain some features of this application, but for detail, you can see our first video, Technology for Research, in which one of our team member, Fahad Fiaz, explained this project in detail. This application, Collaborative Annotation Tool, CAT, is basically developed to facilitate researchers and scholars. CAT is a web portal through which a researcher or scholar can find any research paper. This tool is very helpful for researchers and users. Using this application, a researcher or user can conduct a survey and request other users to tag the paper in the tags defined by the paper owner. CAT also provides an interactive graphical user interface which is very easy to understand and use. Using this application, a researcher has no need to go through all the research paper. This application will go through all the research paper and extract the important information and highlight it for the researcher or user in the form of tags. Here, I want to mention that we have used different colors to display and classify different tags. An additional feature which CAT also provides is the metadata of the research paper. Metadata is the information about the research paper. CAT not only highlight and extract the information from the research paper, but also stores that information and data in an efficient manner in the database for further processing and for further use. This is the brief introduction of this project. Now, come to the technology which we have used up till now. While developing this project, we was using Linux operating system. The major developing work is done in the Python language. We have used many Python libraries. We have used Python for web scraping and for downloading the research paper. We have used Django framework of Python as a server-side language. In the first cycle, we was using PDF Miner, convert the PDF in text file, but it was not giving the accurate output and its working was not as much efficient as we want. So we decided to use the Grobit, get the metadata and the text of the research paper because its accuracy and output is much better than PDF Miner. Grobit gives us the output in the form of XML file, and to extract the text from that XML file, we have used a Python library xml-e3.element. We have used SQLite as a database, NLTK, which is also a Python library for paper processing. We have used JavaScript function js.textHighlighter to highlight the tags and to get the text from the research paper. Now come to the work which we have done in the first cycle. Downloading paper module, in which we were downloading the research paper through Sci-Hub using paper URL, or uploading the paper from the local disk, converting the PDF to text file using PDF Miner, storing the text into database, research paper processing like sentence tokenizing and lemma finding using NLTK techniques, tagging facility on regular tags, displaying the sentences on the basis of lemmas, displaying lemmas, and highlighting the text and tags which user had tagged the text. These were all the modules which we have worked already in the first cycle. Now come to the newly features added from the last evaluation up till now. In the first cycle, we were working on the Windows platform, But now we have shifted our project to Linux platform. We deployed that project on the Ames Lab server, which can be checked on the given URL. As I told earlier that PDF Miner was not working accurately, so we decided to use the Grobit. We have successfully run the Grobit on the local machines and converted the PDF file into XML file. Here is one important thing to notice, that Grobit gives us output in the form of XML file. So now we have successfully extracted the metadata and text and content of the PDF from XML file using etree.element package, and the extracted text, we have successfully that extracted text into text files. Web for annotation. Brad's Rapid Annotation tool. Brad also provides you the facility of tagging text. So we configured Brad server on our local machine to check its working mechanism. Generally, Brad allows you just 4 tags in which you can categorize text. Brad also needs a .nn file to save annotations. Here, I wanted to show you a live working demo of Brad on our local machine, but video is getting a little longer, so I'm going to skip that. Now let's have a quick comparison of Brad with our tool Cat. Brad is a desktop Linux platform dependent application, while Cat is a web-based tool, so there is no dependencies. Everyone can easily use it. Brad does not accept PDF format file. Cat accepts the PDF format file. Brad does not process junk and garbage values. On the other hand, Cat passes PDF file which contains images, tables, formulas, and special characters as well. Brad can annotate text according to predefined text. As I already mentioned, Brad allows you to tag the text in just 4 tags. On the other hand, Cat provides a vast range of tags for annotation. User can define its own tags using Cat. Brad saves annotation using file system technique, while on the other hand, Cat saves annotations in database in an efficient manner. Brad's GUI is very difficult and hard to understand. Cat's GUI is very flexible and interactive and very easy to use.
Now come to the deployment of the project. As we were working on the Windows operating system, to deploy this project, we shifted our project to Linux operating system. We created a Python virtual environment on Ames Lab server, resolved all dependency issues in deployment. We are using Django WSGI server as a server on Ames server, and here is a link, ames.pucit.edu.pk:8083/tagging2. You can check our project live on this URL. Here you can see that our project is live working.
In the first cycle, we were using PDF text miner to convert PDF to text file. But its output was not accurate, so we decided to use the Grobit API. Grobit is a machine learning library for extracting and parsing the restructuring raw documents such as PDF. We configured Grobit REST Service API version 0.50 on our local machine. Our application uses this API to extract the text and metadata of the PDF file. This API provides us output in the form of XML file which has TEI standards tags. XML filtration. Grobit gives us the output in the form of XML file, and now when we have to get the text, we have to extract text from this XML file.
XML file has a specified structure, and to get text from the XML file, we have used xml.etree.elementtree library. Till now, we have successfully extracted metadata and research paper content. Still, we are working on extracting the references of the research paper. Now, I will give you a quick demo of working Grobit, that how Grobit converts PDF file to text file. This is a PDF file, and it is the title of the PDF file. These are the author names, and this is the abstract of the research paper. And we want to convert this PDF into text file. Grobit gives us the output in the form of XML file, and this is the XML file, and this is the TEI structure which Grobit returns us. And now we have to extract the text and metadata of the paper from this XML file. This is the metadata of that research paper which I showed you earlier. This is the title of the research paper. These are the author names, as you can see in that PDF. And this is the text file and the content of the research paper. And now we are working to extract the references of the paper and to store this text and metadata of the paper in the database in an efficient manner. This is the work which we have done up till now. Thank you.